Okay, so the assignment you have in front of you is your one for gravitation here. I will come up with a due date for that here shortly. Okay, so the stuff that's on this one is going to be Newton's universal law of gravitation. Right, so Fg equals big G times m1 times m2 over r squared. Satellite motion, right? Kepler, possibility some of these could be solved using Kepler, okay? And gravitational field strength, the stuff we went over yesterday. All right, that's the three topics that are on this assignment. There are 13 questions. Some of them will take you virtually no time at all. Some might take you a little bit longer, okay? But I think in general, you shouldn't have too much trouble getting the bulk of this completed in class today. All right, make sure you look at the point values, because they'll tell you about how much work should be required for each one. Okay, like for examples 1 and 2, don't overthink those. Okay, they're not terribly difficult questions. Don't overthink them. Okay, but like I said, there may be multiple ways to do some of the questions, especially if it's a Kepler versus satellite motion problem. You may be able to solve some of them using one or the other. But there are a few that I have made on this assignment that can only be solved one way. Okay, and I built them that way on purpose. So keep in mind that if you're going to use Kepler for something, you need to have what? Right, you need to have two measurements for a second object orbiting the same central point. Okay, so if it's planets around the sun, you always have Earth. Okay, but if it's satellites around Earth, then you don't. Okay, so just keep that in mind. All right, for number 3, okay, again, don't really overthink that one. 4 is about Cavendish's experiment there with the torsion balance, okay, the lead spheres and the little pith ones, okay. It's just asking you to find the force of attraction between them. Again, looking at keywords, this is asking for the force of attraction, not the rate of attraction, okay, that we talked about yesterday. Gravitational force between two electrons 1 meter apart is given there. Find the mass of an electron. Something to keep in mind, electrons are all what? Yes, but they're also all identical. Okay, all electrons have exactly the same mass. Keep that in mind. It'll be helpful when you're doing your manipulation on that one. We're talking about 2 electrons. Mass 1 and mass 2 are both electrons. Okay. For number 6, talking about a moon of Saturn. Okay, moons are satellites, so just keep that in mind. Okay, number 7, make sure you're looking at units. Number 7 is not a difficult question, provided you keep the units in mind, as well as looking for keywords like altitude and above the surface and height and stuff like that. Okay, number 8 is a spy satellite that is orbiting. It has an orbital radius of 2 Earth radii. Just as a point of clarification, the only planet we spy on is Earth. So the spy satellite is in orbit around the Earth, not anywhere else. I have had some very creative stuff for this question. The spy satellite is orbiting the Earth. Okay. Then we got one about Mars's 2 moons. Okay. Fairly simple calculations. 10 can give people trouble. Here's what I need to tell you about number 10. You're going to have to remember a little bit about this. You are trying to find the net gravitational force acting on mass 1. Okay, mass 1 is being pulled in 3 different directions, and we want to find the net force acting on mass 1. All right, so you may need to remember how to do this, especially this part. Okay, like what we do with vectors and how we add them is crucial for this one. All right, the other part of this question is something that occasionally comes up. These are arranged in a square that is 1 meter by 1 meter. The distance, however, across a square like that is not 1 meter. Okay, I have people say that it's 1 meter all the time. Okay, mass 1 and mass 3 are more than 1 meter apart. Okay, all the other ones are 1 meter apart, but those two are a little further than 1 meter apart. Okay, corner to corner, it's a little different diagonally. Okay. Number 11, okay, got an asteroid that is orbiting the sun. Okay, it does say that. It's a rotation around the sun. Okay, then we got one about Saturn and finding gravitational acceleration. Okay, and 13, we're looking for the magnitude of the gravitational force, again, between them. Okay, so always make sure you're looking for whether it's field strength or force or acceleration or force. Okay, because obviously you solve for those differently. Questions on any of those? Okay, I will come up with a due date and let you know what it is here right away. It's going to be after your exam. There's just no way around that, I think, at this point, unless I really, no, there's no way. Okay. Yeah.